Okay, here we go. Linear Algebra 2, unit vectors in magnitude and direction form. Oh yeah, all right, oh yeah. Yeah, in case you haven't done so already, you're probably gonna wanna watch Despicable Me after this one just to get Vector, one of the best villains ever. So a unit vector is a vector with a length of 1, a really tiny little vector. The unit vector is a vector of a length of 1. How do we find it? We take a vector, divide it by its magnitude, and that will give us a unit vector. A unit vector is a vector of length 1. It is also 1 in the same direction as the original one. It's just a really tiny little vector. So the vectors I and j, often we can rewrite vectors in different forms. One of the ways is in I and j form. And the vectors I and j are unit vectors, where the vector I is the x is 1 unit in the x direction, and the unit j is 1 unit in the y direction only. Those are components. It is a horizontal component, vector, unit vector of 1, and a vertical vector of 2. Vector can be written as a linear combination of I and j. In other words, how many units do we move over to the right or left, and how many units do we move up and down? That is just changing how we write it, and we'll be doing that in a little bit. Okay. So if we want to, for example, if we have the vector AB, that is same as vector A, 0 and 0b, which is A times the unit vector going to the unit vector I, and B times the unit vector j, so we have AI and BJ. Okay, so we can take a vector A and rewrite it in component form. So we take this vector, rewrite it in this form. That is one of the things we'll be doing. It's very, very easy to do, actually. So for the given vector, find a vector in the same direction with unit length. So in order to find it, what we need to do is we need to find the magnitude. That's how you do it. You want to find a unit, you want to find a vector, a unit vector in the same direction. What you do is you have to find the magnitude and take that vector, divide it by its magnitude. So to find the magnitude, and I'm going to call this vector v just to make it easy, you take the square root of 5 squared plus 12 squared, and you get 13. The magnitude of that vector is 13, so our unit vector would be 5 thirteenths and 12 thirteenths. That's what you do. Figure out the magnitude and you go from there. The magnitude of this one is 4 squared plus negative 15 over 2 squared. You do some fancy footwork and you get 17 over 2 is its magnitude. So what you have is you have the vector 4 divided by 17 over 2, comma, negative 15 over 2 divided by 17 over 2, but we do not want compound fractions in any way, shape, or form. So this is the equivalent of 8 over 17 and negative 15 seventeenths, and that's our unit vector for that one. For the next one here, the unit vector, the magnitude would be the square root of negative 2 squared plus negative 2 squared, which gives us the square root of 8, which is 2 root 2. So that means our unit vector would be negative 2 over 2 root 2 and negative 2 over 2 root 2, which we simplify to negative 1 over root 2, negative 1 over root 2, which ends up being, when you simplify the radical, negative root 2 over 2 and negative root 2 over 2. And then last but not least, we do the same thing on this last one here. We have the square root of negative 7 squared plus 7 root 3 squared, and that ends up giving us 14. Not the square root of 14, but 14. So we have negative 7 14ths and 7 root 3 over 14, which should be recognizable as negative 1/2 and root 3 over 2. Once again, I'd say, are there any questions? But there is nobody here to ask any questions. All right. On to the next one. Sketch each vector and find its magnitude. So, negative 2i plus 3j. This is easy. This is the x component. This is the y component. This is the equivalent of negative 2, 3. So I go negative 2, 3. There is my vector, negative 2i plus 3j. What is its magnitude? It's the square root of negative 2 squared plus 3 squared, which gives us the square root of 13 for its magnitude. Same thing on this one. I go 5/3 and 5 root 3, which is approximately 2.88. So 5/3 is 2 and 2/3. So I go, or sorry, 1 and 2/3. Go 1 and 2/3 over and 2.8 it up. So it's approximately here. Definitely close enough for anything that we are ever going to do. And then the magnitude, and here's the fun part, 5/3 squared plus 5 root 3 over 3 squared. And you end up getting the square root of 100 over the square root of 9, which is 10/9 for our magnitude. So we have our direction and our magnitude. So this one, 3 root 2, 3 root 2. So this is approximately 4.24. Is 3 root 2 is 4.24, so 4 1/4. So I go over 4 1/4, 1, 2, 3, 4 1/4, and go down 1, 2, 3, 4 1/4. So it looks something like that. And then our magnitude is 3 root 2 squared plus 3 root 2 squared, which ends up giving us 6. Easy peasy, right? Okay, given V is 5i plus 4j, and W is 3i minus 9j, find the following vectors. Well, first one's really easy. 6v would be 6 times 1. So I end up getting 30i plus 6 times 4 is 24j. Or I would have 24 if I wrote it in vector form rather than I and j form. Negative v plus w, same idea. Negative 5i minus 4j plus 3i minus 9j. Negative 5, 3, so I get negative 2i. Negative 4, negative 9 minus 13j. So I either have it in this form, or I would have it as negative 2, negative 13. Same thing on this one, only I'm multiplying times 4 first. So let's see, so that would be 20i plus 16j minus 2w, which would be minus 6i, plus 18j. So 20 minus 6 would give us 16i, and 16j plus 18j, and that is supposed to be a 16. Let's see, plus 32j. Sorry, 34, my bad. 34j, so it would be this, or 16, 34. And the last one is actually fairly simple. You multiply those times negative 1/3 times j, so that gives you negative 1i plus 3j, which would be negative 1, 3. Or either one of those would be acceptable. And I'm going to take a short pause. Okay, here we go with the next page. So vectors in magnitude and direction form. So the idea is, rather than writing it as in the standard form we have with the two components, or in the I and J form, we still do I and J, but rather than having A and B be just the numbers 3 and 4, what we do is we work it out to write it in magnitude and angle. Magnitude, direction, form. It's our angle off the horizontal is what our theta is. So we can use either the cosine or the sine to figure out what the angle is once we find the magnitude, or we can use that theta is equal to the inverse tangent of B over A. Yeah. Okay, because what we're dealing with here is we're trying to say, hey, here's our vector here. This is our vector B, goes at this point AB. This is our vector A, B, and it's also the vector AI plus BJ. What we want to do is break it down into its parts. We can think about this as being a right triangle with this is A and this is B, and we can find theta from that. There's our B, so we can use sine, cosine, tangent, whatever. Tangent was what we did before. These will be in degree form, so make sure that you are doing it. Theta is in degrees from what we are doing in here today. Just what you do with vectors if you do it degrees. So write the following vectors in magnitude and direction form. So we need two things to be able to do that. We need our magnitude and we need the direction. So we need our magnitude and we need our direction, the angle. So let's start with the difficult one first. If we sketch it out, we got the 0.34. It's somewhere up here. There's our angle. We need to figure out our angle here. This one's easy. It's first quadrant. Anything we use, we can figure it out. So theta is equal to the inverse tangent of 4/3. So theta equals 53.1 degrees. Use your calculator, set that up and do that one. And the magnitude on this one is actually very easy. Magnitude is the square root of 3 squared plus 4 squared, which is 5. It's a 3, 4, 5 right triangle. So that means we have 5 cosine of 53.1 degrees. That's the J, not the I, my bad. I plus 5 sine 53.1 J is what we get for that one. Next one, same thing. First thing you do, set it up here. I have -6/3, so it's somewhere off of here. If we do theta equals the inverse tangent of 6√3 over -6, we end up getting theta equaling 60 degrees, and what we end up actually getting is we get -60 degrees is what you're doing on your calculator, which is the angle down here. We don't want that one. Our actual angle is we want to add 180 degrees to that to move it around to there. So our angle theta would end up being 120 degrees. Our magnitude, -6 squared plus 6√3 squared. We end up getting 12 for that. So our magnitude and direction form of this one would be 12 cosine 120 degrees. Did it again. Times I plus 12 sine of 120 degrees J. And the last one shouldn't actually be too hard to figure out. We're down here at the point -5,5. Hey, it's the same over, same down. This is 45 degrees here. Add 180 to that. Theta is equal to 225. 45 plus 180. Our magnitude, square root of -5 squared plus -5 squared. You end up getting the square root of 50, which is 2√5. So we end up getting 2 root 5 on that one. Nope, I did that one backwards. It's 5 root 2. Oh my God, why did I do that? See, 5 root 2. So I end up with 5 root 2 cosine of 225 I plus 5 root 2 sine of 225 j. Okay. Find the component form of vector whose magnitude and direction are given. Okay, so magnitude direction. So that means A is equal to the magnitude times the cosine of the angle. So that would be 20 cosine of 120 degrees. And you end up getting negative 10 for that. And B would be 20 times the sine of 120 degrees. And you end up getting 17.32 for that. Okay, which is, I believe, 10 root 3, or who cares? So what is my vector? My vector is negative 10, 17.32. Actually, it's 10 root 3 is what it is. So next one, same idea. So I have my A component is 3 cosine 310, which is 1.93. B is 3 times the sine of 310 degrees, which is negative 2.30. So my vector is 1.93, negative 2.30. And then the last one, and I'm sorry that's a little overlapped on there. Here, I'll move that, make it a little prettier. So A is 10 cosine 250 degrees, which is negative 3.42. And B is 10 times the sine of 250 degrees, which is negative 9.40. So I have the vector negative 3.42, negative 9.40. That's excellent. Okay. And last page on here. So the magnitudes and directions of two vectors v and w are given. Find the magnitude and direction of their sum, v plus w. Sketch the vectors in their geometric sum. So first thing we need to do is you can't just add the points, you can't add the magnitude, you can't add the directions and do that. You need to convert it back into standard form. We just did that. A is 4 cosine 40, B is 4 sine of 40. We just got done doing that. So you get your vector V, ends up being negative 3.06, 2.57, and W ends up being 6.58 and 2.39. We just got done doing that. I'm not going to go back over how to do that one again. So V plus W, you add those points together and you get 3.52 and 4.96. Okay. Now, to rewrite this in magnitude and direction form, you need to figure out the magnitude and the direction. So the magnitude of V plus W is equal to the square root of 3.52 squared plus 4.96 squared. And you end up getting 6.08 for that. And then you end up doing theta is equal to the inverse tangent of 4.96 over 3.52, and you end up getting theta being 54.6 degrees, which means that we end up having our component vector of Actually, it says find the magnitude and direction, so you don't have to do it, but that's our magnitude and our direction. That's good enough. I'm not going to worry about sketching it out. It's not that big a deal. Screw it. Let's do this. So V is something like that. W is something like that. V plus W is something like that. That is good enough for how I feel right now, because it's more important to do the other parts. So same thing on this one. Magnitude and direction, you need to rewrite it in vector form. Take the magnitude times the cosine, magnitude times the sine. And you end up getting V is the vector 3.38 and 7.25. And W is equal to 5 times the cosine and sine. W is 4.76 and 1.55. So V plus W is equal to 8.14 and 8.8. And the magnitude, square root of 8.14 squared plus 8.8 squared. And these are all decimals already, so you just plug that in your calculator, let it do the heavy lifting, and you end up getting 12. Interesting. Magnitude is a unit vector. Not a problem. And then you work out theta to get the direction. It is the inverse tangent of 8.8 over 8.14. That is very close to 1, which would be very close to 45 degrees. And in fact, you get 47.23 degrees. And thus endeth the lesson.